Hello, everybody. I'm Alexy Khrabrov, the organizer of SF Scala, and here on location at Lithium with two talks today, fast parsed by Haoyi Li, and we actually have Haoyi with us.
Hello.
It's great to have you here, Haoyi. It's the first time we actually have you at SF Scala meetup. We had you at some Scala by the Way conferences, but that's your first meetup talk. So this is the first Q&A we get to do with you. And you know that your work is very popular in the community. Your videos have huge following. So folks have always the question how you can do all this, right? And so basically say, you work at Dropbox by day and you play with Scala by night, and by the output you do at least work of 5 or 10 people, at least that's a visible side in the Scala. So how you are able to do all this? Is it your are you super productive? Are you kind of super efficient? Because you create multiple projects. Kind of one following logically from the other. So can you share, do you know how this works?
Sure. So a lot of the projects are actually very old ideas that I have been thinking of for at least 4 to 5 years, long before I started using Scala. The library I'm going to be talking about today is FastParse. Arises from me learning Scala parser combinators back in 2012, which arises from me trying to parse things back in 2011 and 2010.
Okay.
And you try doing something, there are some tools. For example, at the time in 2012, I found Scala parser combinators are very nice. And they solve a lot of problems and no one uses them for real. And you try to find why no one uses them, and it's because when you try to use them, there are certain problems that get in your way. And it turns out in many of these cases, the problems are not insurmountable. The problems are relatively straightforward things that no one has had the time to go and fix and make better. And so FastParse, although itself as a library only took me something like 2 days to implement, is something that I've thought about for at least several years now. I've implemented one parser combinator library before in Python. I've used 2 of them in Scala, the inbuilt ones in Parboiled 2. And then FastParse is the result of this experience.
Okay.
Yeah.
And so parboiled based combinators you use in your Scala compiler, in your Scala parser.
Yes.
Which in turn emanated from Scala Tech, right? So did you write Scala compiler, Scala parser because you had to do it in Scala Tech?
I do not remember why I wrote the Scala parser.
But
I think that was the reason.
Yeah,
I think
because
you're right.
Here's my theory. Correct me if I'm wrong, right? Again. So we all know that you popularized Scala.js. So you did a lot of work on Scala.js. So you're kind of mostly known for really great work on Scala.js, which brought into the mainstream. So here's my theory. So you have a book, Hands on Scala.js, which you wrote for the web, and then you wrote Scala Tech in order to write Hands on Scala.js book.
Yes.
Right. In order to write Scala Tech, you had to have a Scala parser because Scala Tech is fully, Scala compatible, right? So you can have any Scala there, and then parser combinators you need to have to write the Scala parser, right? But the fast parser is the next generation, right?
Yes.
Than the other one.
Yes.
Okay.
So I guess the answer is to how I pick these projects is I build something, I find something that's missing, and I go build that. And often it's not that hard to build. You just need to not make the same mistakes as the past.
Right.
Yeah. And so FastParse is a logical conclusion, and FastParse has its own bit set and other stuff inside that I had to build because the standard library versions were not good. And I don't want to build as much as I do, but given the tools that are available out there and the tools I think I can make myself, it is in my opinion, the correct answer.
Yes.
How to get these things out. And then the reason I package them up as individual libraries rather than having just one huge project is because I don't have time to maintain a huge project, and if I want these things to stay alive, I need to get other people to use it, at the very least to give me bug reports and send in bug fixes as they find them. And that's why every project I make, I package it up very nicely, put it on the internet with swaths of documentation saying, this is how you use it, go and use it, don't need to ask me any questions, it's all here.
Right.
And it's the same for Scala.js. I have something like 6 different projects I work with Scala.js. All of them can work completely independently. And it's for the same reason, like I can't maintain a Scala.js web framework. I don't have the time to do that.
Right.
But I can maintain a bunch of libraries, and it's much easier to get people to buy into one library than it is to get people to buy into a huge framework.
Yes.
And that's why I've done it in this way.
Okay, that's good to know, because a lot of people are wondering, why don't we have a Scala.js based web framework, which will be like Play, right, or like Ruby on Rails before, and now especially with Akka HTTP, it seems like a very reasonable backend for that, and somebody should go ahead and package that, right? But we don't see this quite yet, and that's like an interesting question. And I understand it's probably a lot of work, like more than one person, right? So do you think this is because Scala.js itself is more complex than kind of typical front ends like Angular, or should it just stay the same way? Like everybody should figure out their own backend and figure out their own way to connect, Scala.js to a backend.
I think that currently Scala.js is largely early adopters. That's one issue. Another issue is that Scala.js is a whole new world and whole new way of doing things. Like people have used Scala for a long time on the back end. Using Scala for interactive interfaces is a completely different experience.
Yes.
And so the best practices have not yet been discovered. Like people have tried many different things. Many of them have failed. Some have succeeded. Some of mine have succeeded. Some of mine have failed as well. And it's not clear what will win out in the end. And it seems a bit, to me at least, it's premature to say that we know what we're doing. We're going to build an awesome framework, because honestly, we don't know what we're doing. And like every week, every month, someone tries a new thing, and maybe it'll work, maybe it won't. And I think that over time, as the community grows and matures, some best practices will win out naturally, and those will become the web frameworks of the future. And for me, I don't have the manpower to make a framework myself. Maybe if I was working full-time on this, I could, but I'm not. I'm doing this maybe 10, 15 hours a week. And so my goal is to get as many other people excited as possible in order for them to get to do work for me without me having to pay them money.
Right.
And that's why I do it in this way.
And we definitely want to help you in all possible ways, right? So I think like a lot of folks who, see your work, they are really motivated to try it. And so, as you mentioned, like, last Scala by the Bay conference, there were 4 talks about Scala.js, and you basically said, like, there are 4 talks about this in Scala by the Bay. I'm not doing any of them, and so my job is done, right? So and then you did a talk on Ammonite, which is the new kind of REPL. So I must ask here, because, like you mentioned that, something was not done properly, and you decided just to do it properly. So I think this is a fundamental difference. Majority of people will be afraid to tackle something like Scala parser or JVM. So you have like a model of JVM, right, in JavaScript. In Scala, right? And so this is interesting, right? Because for most people, when they need to do something like they generally will pause and say, okay, Scala parser. Martin Dorsey spent years writing Scala parser. I'm not going to write Scala parser, or JVM obviously, right? Or Sun Oracle spent centuries on this. I'm not going to try this. So, but you basically you try this and you show that you have your Scala parser is about 1,500 lines, and it parsers 99% of Scala. So you actually demonstrate that these things which are nominally complex can be easy, or you make them look easy. So I wonder, how do you know? Because a lot of people don't do this because they don't think it's doable. And so you kind of, make this kind of bold claim and you just kind of share a result. So how do you know, like, what's doable, what's not? How do you know before you approach, like JVM and Scala that it will be doable? And why are you not afraid to just kind of try this stuff?
Every project has its own judgment and own motivation. The Scala parser arose from my experience that using Scala parser combinators makes it very easy to parse complex syntax very quickly in like dozens of lines of code rather than thousands. The JVM, on the other hand, arose from the fact that one of my friends had written a JVM in CoffeeScript. And I looked at his JVM and it worked. It can run the Java compiler in the browser. It can run Rhino. It can run Kawa scheme. And it was like 3,000 lines of CoffeeScript. And I thought, well, if this guy who I know can write a JVM in 3,000 lines of CoffeeScript, I'm sure I could write a JVM in about the same amount of Scala. And so I did. This is a case of you thought something was impossible. Someone else demonstrates that this is not impossible. This is actually doable. And so you go and try and do it yourself and see how far you get. So that's for that project. So the other project, for example, my functional reactive programming library, Scala.js, arose pretty naturally out of refactoring a bunch of front-end UI code. I just refactored it. First question is, OK, I don't know where to update the UI. The first question is when I first render the UI, changing the bits that you care about is annoying. OK, so you make it such a way, render the UI, you can just say re-render, and you'll re-render the whole chunk. The next problem is, well, which chunks do I want to re-render? And then, OK, so you try to keep track of which chunks depend on which other chunks to re-render before when you change something. And after that, you refactor it a bit, and you get this nice library. And then I took this library, which was made for some freelance project, and I looked at this project called Scala.react that's done by Martin's lab in EPFL. And it's like, OK, this project, Scala.react, seems like exactly what my freelance project needs. In fact, I almost had the same thing. So I tried to download that project. Like most academic projects, it doesn't work. It doesn't compile. You make it compile, it blows up at runtime. You make it work at runtime. And after a while, you hack it together, and it kind of works. And you realize that, well, what's the point? I already basically implemented the parts that I care about. They actually work. I don't need to depend on someone's PhD thesis. And so that's how that came about. The templating library I made, Scala tags, is actually something like the 7th templating language I have written. Among them, like 1 in PHP, 2 of them in Python, 1 in C#, 1 in F#, and then this one is in Scala. So maybe it's a bit obsessive to have done so many of them ever since I started doing web programming in 2010. But as a result of all this experience, writing this one was relatively straightforward because I knew what I wanted it to look like. I knew how I wanted to use it. So every project's different, I guess.
And that's actually, you've been validated because I think Scala text is now being used outside Scala.js. It's been used as generally, HTML generation in Scala, right? So I think, all this experience kind of converged and, people are using it. So again, it's kind of interesting. So I think you're kind of, you're following kind of a new path or your own path because a lot of people who in technology world get so excited about technology that basically once they find the technology they like, they usually start doing it 100%, right? So and eventually find a way, if they create new software, they found a company around this and they basically, spend all their time. So, and obviously you have so many different things, you can pick one of them and basically spend all your time doing this, but you basically maintain this balance, right? And you basically say, you write Python and JavaScript by day. Are you excited about this Python JavaScript? Like what keeps you doing this, like outside of all kind of business and kind of jobs and other aspects? I'm just wondering technically, right? Like, is this Python we are working on, is this as intellectually satisfying as, the Scala and Scala.js? Or kind of how you, like, why wouldn't you, not like go all the way and do everything with Scala.js or kind of, focus on one of these technologies which you are developing? Because there are very many ways that can be, lead to kind of new businesses and startups and all whatnot, right? I'm wondering, how do you maintain this balance between kind of, boring Python and JavaScript on the one side and kind of exciting Scala and Scala.js on the other side?
So I had an offer to go write Scala full-time in the winter of 2014, and I've had several people contact me, but that was the only time I followed through and got a concrete offer. And I decided not to take it because I've decided that a lot of the work I do in Python and CoffeeScript at Dropbox and open source in the Scala community is actually very complementary. As an example, I would not have written FastParse, the library I'm going to talk about today, if I had not written a different parser combinator library in Python before, not at Dropbox, that was before in school. I would not have worked on Scala.js in my open source time if I had not spent a bunch of time working on the web in Dropbox, at Dropbox in CoffeeScript and Python. At Dropbox, there's a bunch of tools that we have, and one of them, for example, is a static analyzer that crawls your CoffeeScript, crawls your Python, makes sure the names line up, and enforces basic invariants. It can't enforce types, but it enforces basic things like names have to be defined somewhere.
Right.
I would not have written that at Dropbox if I did not have my experience working open source in various Scala projects. And there's a lot of this kind of cross-pollination that, in my opinion, has been very valuable. I would not have written the Ammonite Scala REPL if I had not used the IPython REPL every day at Dropbox. And if I had not used needed a good REPL to work on my static analyzer at Dropbox. And because I wrote this nice Ammonite REPL, I now have a static analyzer at Dropbox, which can query, like, find me all the dependencies of this file, union with all the dependencies of that file, and filter those that start with something. So that's the sort of thing you need a good REPL for, and the work open source has benefited my work at Dropbox. My work at Dropbox has benefited my open source work.
Yep.
And I'm probably not going to give it up so soon.
Got it. Okay. No, that explains. So Dropbox provides kind of industrial motivation. Software used by millions of people. So you see like what really works at scale, and then you kind of take the learnings and apply them to different domains. Well, that makes sense. So again, like a lot of people are very curious how you can do all this. So maybe you can share a little bit of your background. So like at what age did you start programming? How quickly did you learn programming, and kind of what were your like first programming languages? What like most interesting experiences kind of growing up as a developer?
Sure. So my first programming language was XML, and I was modifying user interface files for my EverQuest user interface. You can move around where a health bar is shown or what color your health bar is, and that is all done by modifying these XML files which represent the user interface. Maybe that doesn't count. After that, my next experience programming was in the Warcraft 3 trigger editor. So this is something which you use to make the Warcraft like interactive campaigns for the game. You can say that, if a player walks into an area, when you define an area by dragging and dropping an area on the ground, perform action. What is the action? They click on the list of possible actions. Maybe select the if statement. If, and then there's a condition you can click on, there's an action you can click on, and then there's an else you can click on. And you can have for loops, you can have variables, you can have objects, you can have arrays, and you have all sorts of things you can do with this trigger editor. It's underlying this trigger editor, you have this language called Jazz, which is only used by Blizzard for their games. But I never actually went that deep. So I spent several years fiddling with that, probably so I wrote my first XML probably when I was 11 or 12 years old. I spent time fiddling with Warcraft World Editor and Trigger Editor from maybe like 13 to 14, 15 years old. And when I was 15 years old, a bunch of people in my school, which had at that point just signed up to do the International Baccalaureate program, which is an international program that other schools do, got together and said that, hey, this program, which everyone else seems to do, optionally has this computer science course. This is addition to like math and physics and history and geography, and biology can do computer science. So a bunch of us I think in here would be called grade 9 and grade 10, got together and say, hey, can you provide us a computer science course? Because we're not yet at this level we're going to do the real baccalaureate, but maybe we're getting ready for it.
Yes.
So there may be like 20 of us, a bunch of us got together in the school computer lab every day after school, and we learned programming. And during geography class, which we didn't take, we would go to the library and work on our programming homework. So in that course, we basically spent 2 years learning Java. And it was great. We didn't learn anything fancy, but basically everyone could come out knowing how to work with the computer. And I believe like 4 of the people in that 20-person course are now in the Bay Area.
Okay, interesting.
So after that, I spent a bunch of time. After that, from grade 11 to 12, I didn't do any official programming courses, but I did my own work, like in my free time, which at the time was making games until I realized I would never be able to publish any games because back then Android App Store and stuff didn't exist, and I wouldn't be able to afford like making boxes to sell the games in the shops. So after that, I gave up on games and did my 2 years of military service and then went to MIT. And from there on, I learned how to do programming for real.
Awesome.
Yeah.
So where was that school?
This is Anglo-Chinese school in Singapore.
Okay.
Yeah.
That's awesome. So actually, you didn't really start like this, 3 or 5 years old. Like you actually did in your teenage years, and kind of it's interesting, right? Like, and I guess we kind of need to wrap up. So I'll just ask you, since you kind of arrived at these projects by thinking of many years and then converging and accumulating kind of a result, what is in the pipeline? Like, what should we expect from you in a few years? Like, what are you thinking about right now? And kind of recent things are Ammonite and FastParse. What do you think will be next?
It's hard to predict what will be next. So far, my approach has been entirely greedy. I will see something that's immediately obvious, I'll go do it, and then I'll sit back and wonder what I'm going to do with the rest of my time. And then I go back to work on Python at Dropbox. the reason I've spent so long working in Scala in particular is because I think that Scala as a language has a really elegant core to it, has a really elegant core to semantics. For example, in Scala, basically everything is a name or a function calling, or a name calling a function. Not quite, but almost. And much more so than even in other functional languages. Like more things are functions in Scala than they are in Haskell or F# or other languages. And they have this really elegant core in Scala that's sandwiched on the top by really crappy superficial syntax that's really confusing. It's sandwiched at the bottom by a really slow compiler that's a huge pain to work in. And it's sandwiched at the sides by, in my opinion, not very good libraries. Like, especially given what they could be. Like, compare using a library in Python versus using a library in Scala. The Scala version usually has a million more types, a huge amount of confusion, and doesn't actually do what you want. Whereas in Python, it does what you want immediately.
Yes.
So I think that if I want to get to a place where I'm happy with programming, this is probably the closest I can get, because reinventing the core semantics is really hard. Reinventing libraries is easy. You can write as many libraries as you want. If you're not good, you throw them away, write another one. Reinventing syntax is actually also relatively easy. Reinventing a compiler, I don't know. But so far, I think that we can bring Scala to a place that's much, much better than we are now. And for me personally, I think that by working on Scala, I can bring my own personal happiness programming much further than I would be able to if I had started my own programming language, or if I had put the equal amount of effort into Python or Ruby or JavaScript. I think that Scala is probably the most promising in terms of making my life better.
All right, this is super exciting. Thank you very much for sharing, and we're looking forward to your talk.
Sure.
Thank you.
Thanks.